Hello students, so here is the next video from the chapter Current Electricity, and it is about electromotive force, that is EMF. So in the previous video we have studied about electric current, that rate of flow of charge is called electric current and its SI unit is ampere. It is equal to Q upon T, that is Q charge and time T, and the direction that we take for electric current is from positive terminal of the battery to the negative terminal of battery, that is the direction of conventional current, right? So now moving to the electromotive force. To understand electromotive force, we have to split this phrase into three sections: electro plus motive and force. So यहाँ हमें क्या पता लगता है that the force needed to move an electric charge is called EMF. The force needed to move an electric charge is called EMF, but actually it is not a force. अगर आपको किसी भी इलेक्ट्रिक चार्ज को मोशन कराना है तो उसके लिए यू नीड अ सोर्स that can provide energy to that charge. So basically it's all about the energy जो कोई सोर्स किसी इलेक्ट्रिक चार्ज को देगा for its motion is called electromotive force. To understand this we need a source, or the very common source that we have is a battery. तो बैटरी क्या होता है? बैटरी is a device having two terminals and an electrolyte or a chemical solution in between it, and maintain a certain potential difference between the two terminals. Okay, so here I am going to plot a schematic diagram of a very common battery. Very basic diagram it is, that it consists of two terminals, terminal A and terminal B, and these two terminals consist this battery having some electrolyte or chemical solution filled in between these two terminals A and B. Now what happened? Since electrolyte is a chemical solution, so some chemical reactions will go inside it, and due to this chemical reaction वहाँ पर कुछ chemical force produce होगा. Now this chemical force, we called it chemical force, is totally different from electrostatic force. That's why we also called it non-electrostatic force. Non-electrostatic force, or we represent it with Fn, right? तो अभी मैंने बोला that this non-electrostatic force is totally different from electrostatic force. Now what is the difference between the two? We know that in electrostatic force where exist two charges, suppose if the charges are positive, it will show repulsion. If negative, again repulsion. If positive, then attraction. Okay, this is the nature of electrostatic force. I consider it as Fe. But here the force exists inside the battery due to chemical reaction is chemical force Fn, which is opposite to electrostatic force. It means it will show a force where positive move towards positive and negative move towards negative. Like positive moves towards positive, so all the positive charge accumulate on one side and all the negative charge will accumulate on the other side of the battery. Means we have two terminals, so because of this non-electrostatic or chemical force, all positive charge get accumulated on one terminal of the battery while all negative will accumulated on the other terminal of. So जैसे जैसे यहाँ पे चार्ज accumulate होगा on the terminal A and terminal B, and electric field also set up there. Now ये electric field क्या करेगा? इस इलेक्ट्रिक फील्ड की वजह से इन चार्जेस पर जहाँ अभी तक सिर्फ नॉन इलेक्ट्रोस्टैटिक फोर्स था, एक इलेक्ट्रोस्टैटिक फोर्स भी एग्जिस्ट करेगा, राइट? तो दिस फोर्स Fe, electrostatic force, will be equal to QE. Now suppose there is a positive Q charge, which was moving towards the battery terminal A, due to the force Fn. Now there exists another force, that is electrostatic force, which is from positive to negative, which take this positive charge from positive to negative terminal of the battery, and it's equal to QE. अब ये प्रोसेस में क्या होगा? अभी हमारे पास इनसाइड द बैटरी दो फोर्सेस एक्ट कर रहे हैं, वन इज नॉन इलेक्ट्रोस्टैटिक एंड वन इज इलेक्ट्रोस्टैटिक, एंड बोथ आर एक्टिंग टू opposite to each other. So this motion of charges will continue till the time these two forces balance each other. Means जैसे ही हम Fn is equal to Fe के situation को अचीव करेंगे, we will get a steady state inside the battery. Means motion of charges stop. Okay, so while achieving this state, positive charge move towards positive terminal because of the non electrostatic force, and positive charge move towards negative terminal because of the electrostatic force. And the point where these two forces balance each other, we achieve a steady state, and there will be no motion of charge because of these forces. Now अब आता है इलेक्ट्रोमोटिव फोर्स. इस सिचुएशन को अचीव करने के बाद, if now we want to move a positive charge from negative terminal of the battery to positive terminal of the battery. Now if we want to move a unit positive charge or Q charge from negative to positive terminal of the battery, then some work is needed. Now this work done per unit charge is called EMF. So basically EMF is the work done to move a unit positive charge from lower potential to higher potential. All right, EMF क्या है? EMF is the work done by the non electrostatic force. This work done W is by the non electrostatic force and is given as Fn into D. Means electrostatic फोर्स से ये वर्क डन नहीं हो रहा है, ये वर्क डन होगा नॉन इलेक्ट्रोस्टैटिक फोर्स और केमिकल फोर्स से. तो Fn इंटू डी, दैट इज डिस्प्लेसमेंट, जितना चार्ज मोशन करेगा, Fn into D will give work done, and this work done per unit charge gives EMF E. Okay, so electromotive force for a source can be defined as the work done by the source in taking a unit positive charge from lower to higher potential. As we have discussed कि बैटरी के नेगेटिव टर्मिनल मीन्स लोअर पोटेंशियल टर्मिनल से उसके पॉजिटिव टर्मिनल मीन्स हायर पोटेंशियल टर्मिनल तक जाने में जितना वर्क डन होगा पर यूनिट चार्ज इज कॉल्ड EMF फॉर दैट सोर्स. Now what will happen if the terminals of the battery are not connected? It means we are talking about an open circuit, or the terminals of a cell or a battery are not connected. Then what will happen? In this case, the forces, that there were two forces, non electrostatic force and electrostatic force, Fn and Fe, which were equal for steady state that we have already achieved. So Fn is equal to Fe, and these will be equal to QE, because we know that electrostatic force is equal to charge into electric field acting on the charge. So Fn is equal to Fe is equal to QE. So the work done by these forces will be Fnd is equal to Fed is equal to QEd, where d is the displacement shown by the charge. But we know that E into d, electric field into displacement, gives us potential V. So what we get that Fnd or Fed is equal to QV. So EMF E, or sometimes we write it by epsilon. In some books we can get it denoted by. So EMF E or epsilon is given by W upon Q, where W is equal to Fn into D upon Q is equal to Q upon V upon Q is equal to V. That is potential difference when the circuit is open. This is the case when circuit is open. So we can say that EMF of a source is equal to the maximum potential difference. In case of open circuit, we get maximum potential difference between the terminals. So EMF of a source is equal to the maximum potential difference between the terminals. But condition क्या है इसके लिए? Between the terminals when circuit is open. Means we have not connected any circuit element, or there is no closed circuit with that battery. All right. But what if we have a closed circuit? Now if there is a closed circuit, it means battery is connected to some circuit element, or just by conducting wires, means there is a loop completing the circuit. So in that case we can define this EMF of the source as the energy supplied by the source, in taking a unit positive charge once round the complete circuit. In taking a unit positive charge once round the complete circuit. So कैसे define कर रहे हैं हम closed circuit के लिए? For closed circuit, EMF can be defined as the energy supplied by the source. ये बैटरी जितना energy supply करेगा to move a unit positive charge once round the complete circuit. एक साइकिल कंप्लीट करने में इस सर्किट का कितनी एनर्जी नीडेड होगी वो सप्लाई करेगा सोर्स. तो सोर्स ने जितना एनर्जी सप्लाई किया, दैट पर यूनिट चार्ज इज कॉल्ड EMF for the closed. So after understanding the concept of EMF or electromotive force, the next thing we should know is the SI unit of EMF. So SI unit of EMF is volt, and we denote it by letter capital V. Okay, so what is 1 volt? 1 volt EMF को हम कैसे define करेंगे? We know that the EMF E is equal to W upon Q. If W is equal to 1 joule and charge Q is equal to 1 coulomb, then this EMF E will be 1 volt. So using this relation, we will define the value 1 volt. So how will we define this? If any cell supply energy of 1 joule, means अगर कोई भी cell 1 joule of energy supply करता है to move 1 coulomb of charge through the whole circuit. पूरे सर्किट में 1 कूलाम चार्ज को फ्लो कराने के लिए अगर कोई सोर्स या सेल 1 जूल ऑफ एनर्जी सप्लाई करता है या वर्क करता है, देन द EMF of that source or cell is said to be 1 volt. So 1 volt is defined as if an electrochemical cell supply an energy of 1 joule for the flow of 1 coulomb of charge through the whole circuit, then its EMF is said to be 1 volt. Okay, so 1 volt is equal to 1 joule per coulomb. So here comes a point that both in case of EMF and in the previous chapter we have studied potential difference V. Both in these terms we use SI unit volt, formula W upon Q, units joule per coulomb. So the main topic arises here is what is the difference between potential difference that we have studied earlier and EMF. पोटेंशियल डिफरेंस और EMF के बीच में डिफरेंस क्या क्या है. सो वी आर गोइंग टू डिस्कस दैट नाउ, द डिफरेंस बिटवीन पोटेंशियल डिफरेंस एंड EMF. ऑल राइट, सो द first major difference between the two is, so EMF is, as we have studied in the definition, it is the work done in taking a unit charge from lower to higher potential or one complete round throughout the circuit. EMF में हमें या तो पूरा एक सर्किट का कंप्लीट राउंड करना है या फिर चार्ज को लोअर पोटेंशियल से हायर पोटेंशियल पे लेकर जाना है, उतने में जितना वर्क डन पर यूनिट चार्ज होगा that will be EMF. While in case of potential difference, whole circuit is not necessary. Higher potential तक जाना from lower potential is not necessary. It can be between any 2 points of the circuit. It means work done in taking a unit charge from any one point to another point of a circuit is called potential difference. Complete circuit होना या lower potential से higher potential पूरा cover करना is not necessary. Okay. Next difference is similar to the first one only, that potential difference exists between any 2 points of a closed circuit. Whole circuit होना compulsory नहीं है. While in case of EMF, it is the maximum potential difference between the two terminals of the source, and with the condition that the source is connected to an open circuit. हमने जैसा अभी EMF के definition में समझा था, for an open circuit जो भी हमारे बैटरी के या सोर्स के टर्मिनल्स होंगे उनके बीच का मैक्सिमम पोटेंशियल डिफरेंस इज कॉल्ड EMF. मीन्स उस समय वो सर्किट जो आप यूज़ कर रहे हो वो ओपन सर्किट होना चाहिए, लूप कंप्लीट नहीं होना चाहिए, तब हम उसको बोलते हैं EMF. वाइल potential difference is in closed circuit and between any 2 points of that closed circuit. Same point here also, potential difference exists only when circuit is closed, and EMF can be present in even when the circuit is not closed. Okay, now the fourth one is important, that potential difference is an effect while EMF is a cause. Right, fourth one is potential difference is an effect while EMF is a cause. What does it mean? It means when we apply an EMF in a circuit, potential difference is caused due to that. जब हम सोर्स लगाते हैं किसी सर्किट में तो उसके पास उसका EMF ऑलरेडी होता है, बट उस EMF को लगाने की वजह से सर्किट में पोटेंशियल डिफरेंस हमें मिलता है. तो पोटेंशियल डिफरेंस इज एन इफेक्ट ऑफ EMF, or we can say EMF is the cause due to which potential difference exists. Okay, right. Next difference between the potential difference and EMF is, in a closed circuit we have many circuit components, so every circuit component has its own potential difference across its ends. Suppose हमने resistance लगाया है in any closed circuit, so इसके एंड्स के पॉइंट हैं ए और बी, तो इनके बीच में अपना अलग एक पोटेंशियल डिफरेंस होगा। अगर मैंने यहाँ पर एक और रेजिस्टेंस लगाया होता, लाइक सर्किट इज लाइक दिस, A, B, C, then potential difference between A and B is some other quantity, while potential difference between B and C is some other quantity. So every circuit component has its own potential difference across its ends. While in case of EMF is actually the sum of potential differences. EMF is the sum of potential differences across all the components in the circuit plus the potential difference required to send the current through the cell itself. Means किसी भी सर्किट में हर सर्किट एलिमेंट का कितना पोटेंशियल डिफरेंस है, प्लस जो भी आपका सोर्स है उससे कितना पोटेंशियल डिफरेंस रिक्वायर्ड है टू सेंड द करंट थ्रू द सेल, दैट पोटेंशियल डिफरेंस, इन सब का अगर हम सम करते हैं देन वी गेट EMF of the source. Another important difference between potential difference and EMF is that EMF is independent of external resistance of the circuit. सर्किट में जितने भी सर्किट एलिमेंट्स या एक्सटर्नल रेजिस्टेंसेस हैं उनका कोई इफेक्ट EMF पर नहीं आएगा, बट इन केस ऑफ पोटेंशियल डिफरेंस this external resistance affect the potential difference. Their presence make the potential difference always less than EMF. एक्सटर्नल रेजिस्टेंस होने की वजह से पोटेंशियल डिफरेंस की वैल्यू हमें हमेशा EMF से कम मिलती है किसी भी सर्किट में, while EMF is independent of those external resistances. So students, that's all for the electromotive force EMF. I will be back soon with next video from this chapter. Till then you study these topics, and if you have any queries or doubts regarding these topics or any other topic from this chapter, leave the comment below. I will try to sort it out as soon as possible in my coming videos. Thank you.